Okay. Okay, there we go. All right, now I'm going to start by sharing my screen. Oops. Okay. All right. There's this program called the Wolfram Cloud. I mentioned it in one of the announcements, or maybe a couple of them, and maybe even on the syllabus. I can't remember, but um, it's a program that's kind of similar to, I don't know if you guys have ever worked with Symbo Lab. I know that's a popular one that Calculus 1 students use. It basically allows you to do a lot of the work that we do analytically on using a computer. And what I mean by analytic is a normal calculator is going to give you decimal answers, right? You type in something, decimal answers. But to do something analytically would mean it can do stuff symbolically. Like, for example, if you're talking about the derivative of the sine function, sine of x with respect to x, it can actually output the cosine of x, which is the derivative. So it can do integration, it can do limits, and that doesn't even touch at the number of things it can do. In fact, our textbook was coded entirely in Mathematica. So I'm going to give you kind of just a soft introduction, just show you a few things with it. So let me log in and show you where you can find a little bit of resources for learning it, and then I'll kind of show you how I learned it. And let me go into our course here. Okay. All right. So if you go into our course, which looks something like this, I have the teacher version, but it looks very similar. I put a link over here to the Wolfram Cloud. It's just wolframcloud.com if you want to access it on your own. But essentially what you're going to do is you're going to log into this program. You're going to have to create an account. And once you log in using your username and password, so just create one, it's free. You'll come to a page that looks like this. And you can kind of ignore everything here for right now. You're just going to go ahead and click New Notebook. And if you click that, what'll happen is a notebook will open on the left. This is a mathematical notebook allowing you to write in typeset documents like a textbook, but then also you can include line by line code, which will execute line by line. So it's not like a normal program where you have to type in a whole bunch of lines and compile it at the end. You just type in anything you want and it'll compile it. It's a very robust program. Um, I put an introduction to this program in our course. If you scroll down to the very bottom, there's a little section here. It says Wolfram Cloud Information optional. And I put an introduction right here. So what this does is just links you to a page which is kind of developed for math people. And it starts off very basic. And basically, when you click Get Started, it's going to take you through the basics of the program. I would probably, if I were you, just kind of work through a few of these. It only takes a few minutes. They're very short. It'll show you how to enter notation, how to execute it. You always press Shift Enter to execute the code, and then the output will show in the line below. Shows you, and it's only just like a, page and a half, 2 pages at maximum. Starts off very easy with fractions and decimals, and then variable functions. And then it gets into some basic algebra. You might find this helpful in the class. For example, this function right here called factor. You'll notice that what it does is it takes the polynomial, the argument here, and it factors it. Now, all function calls, anything that you're going to call from the Wolfram Cloud, make sure that the function call is capitalized, capital F. And you'll see what it's done is it's factored that polynomial. This is invaluable, right? So when you're working on some of these problems and you do the work by hand and maybe you get stuck a little bit, or maybe you just want to check your work, this is a nice way to kind of aid in your learning. It's not to replace your learning, right? But it's a good way to kind of check your work, investigate things. Here's another one you might find useful. Solve. This is a function called solve. You'll notice the S is capitalized. Um, The argument is inside these square brackets. This is the equation that you're solving. You notice there's a double equal sign there. That's what you need for all equations. And this is the variable you're solving for. You'll notice what it's doing is it's finding the two solutions to this. You could do this by hand by factoring of the quadratic formula, and there's two solutions, -6 and 1. You can also use NSolve, which gives you approximate solutions. So this is giving us approximate solutions out to 5 decimal places or 6 decimal places, depending. Um, you can even solve systems of equations. We're going to run across some of these later. You'll have two equations, right? This is a nonlinear system. You got two equations, two variables, x and y, and this says solve both equations, solve the equations for both x and y. So here's one solution, 2, 9, and here's another solution, 530. You can also find roots. Basically, you're just solving the equation for x. And it's writing the solution as x equals -4. That means or, the double parallel lines there, x equals 1. Anyways, work through this. Pretty cool stuff. You can also do plots in 2D if you want to plot a very basic function. Here's a polynomial. You're plotting it from -10 to 10 in the domain. That's what the graph looks like. You can do region plots. You can plot multiple functions, x cubed, x squared, and x. You can, we're plotting all of them from -2 to 2. Over here, you can include a legend, plot legends. It's just using the expressions for the legends. They're color-coded to remind you which function is which. You can fill to an axis. This is great for integration because you can see the area underneath the curve all the way to the axis. You can combine different types of plots. Here's a regular plot. Here's a region plot. There's also a package for geometry, trigonometry. You can expand trig functions. You can factor. You can solve trigonometric equations. You can specify a domain when you're solving too. If you don't want to get all the solutions, you just want the solutions between 0 and 2 pi, you can do that too. We're going to work in polar coordinates at some point this semester, so this will definitely come in handy in that section. These are tricky. Exponential and logarithmic functions. For the natural log, you're going to use a capital log. I know that's strange because I bet when you guys learned logarithms, you used log for the general log, and then you choose the base. The way computers work is they understand everything's in base E essentially. So log, and then that's the Euler's number E squared. So the log of E squared is just 2. If you want to specify a base, which you don't really need to do that much in this class, you can do it right there. Log base 2 of 64 is 6. Can plot log functions, so on and so forth. But then we get to the calculus. In taking limits, by the way, I'm going to show you this. We're going to try some code here in a few minutes. You can take limits. You're going to take the limit of this function as x goes to 1. That's the notation you would use. Here's a limit at infinity. Limit of this function as x goes to infinity. You can play around with those. It takes derivatives, use the capital D notation. This is differentiating the x to the 6th function. This tells you what variable you're differentiating with respect to. So we're differentiating x to the 6th with respect to x. And of course, that derivative is just 6x to the 5th. If you're wondering why we have to specify what the variable of differentiation is, when you move on to Calc 3, we're going to be differentiating functions of more than one variable, and then you need to specify which one it is. In Calc 1, there's only one in a single variable calculus like this class, there's only one variable, but it's pretty straightforward. You can also use a prime notation to evaluate a derivative. You can define functions, you can plot them. In this particular chapter that we're working on, we're focusing on integration. In fact, a lot of this class is integration. So the one you're probably going to want to use the most is this integrate function. Here we're integrating 8x to the 4th with respect to x. So this is the antiderivative, essentially, 8x to the fifth over 5. You can also use this alternate notation by pressing escape, INTT escape. However, I'd probably stick with just the coding. Um, you can evaluate definite integrals. Um, for example, this one we're integrating this function with respect to x from 0 to pi to 0 to pi. This one, the n, just means we're getting an approximation because the analytic answer is way too messy, and that happens. We are going to be working with sequences and sums and series later on in the semester, and that will be very valuable. And here's some other stuff on plots, polar plots, and some other stuff. So that's kind of a real quick introduction. There's, of course, way more than that. This stuff down here is more multivariable calculus, some linear algebra, statistics, and some other stuff. But that should get you started. But what I want you to notice is that if you click one of these, you'll notice it copies it. And then when you go back to the Wolfram Cloud and we open this up and you click New Notebook, you can just copy and paste. So it'd be a Command V on a Mac, or maybe it's Control V on a Windows machine. It just copied the code right in. And in order to execute the code, you're going to press Shift, Enter. And there's the code. Now, there is a ton more that you can do with this single function. For example, you can do something like this. If you want to change the style to like red, something like that. Shift Enter again. If you want to, let's say we want to plot sine x as well. I'll put a comma there. I need to put these curly braces around, and now it's going to plot both functions. There's the sine function. Of course, it's kind of squished down. Let's say I wanted one of them red and the other one blue. Could do that. Let's say I want to get a better idea of what this sine function looks like. So in this case, I can change the plot range. So first I'm going to do the x from, let's go from -5 to 5 in the x dimension. And let's go from -3 to 3 in the y dimension. It's basically going to zoom in and give me that picture. Actually, let's go out further. Let's go 2 pi to 2 pi in the x dimension. There it is. See that? It's basically, this is the window I'm looking at. -2 pi to +2 pi and -3 to +3. You can also change the ticks. If you want these to be in increments of, multiples of pi over 4 or something like that, you can do that too. There's a ton. You can put in plot legends, expressions. By the way I'm doing that here, plot legends, you'll notice that the possibilities pop up, and if you click one of them, it'll fill it in and it gives you some options, and I'll pick expressions here. Press Shift Enter, and now it's giving me a legend. The red one is sine x and the blue one is x squared plus 2x plus 1. Okay, now let's say that there's a ton more here. Let's say you're interested in what this function actually does. If you type in plot and click I, what'll happen is it'll open up the documentation center here, and it'll open the plot, the definition or the uses for the plot function. And you'll notice what you'll see is some different syntax here for the different ways you can use it. We're basically using this one, but there's different possibilities. We're using this one. We're plotting two functions. If you click this, details and options, it'll go into probably more detail than you ever need, but there's a ton of stuff that you can do. Let me close that up. But what I like is down here. If you go down below, you can see that there's some basic examples. For example, this one right here, let's say I look at this and I say, oh, I kind of like that. If I click here, it's going to copy to the clipboard, and then I can just paste it right in, execute the code, and now I've got the same graph. In other words, if you find something interesting over here, you can actually copy it in, paste it, execute the code, And then you can play around with it. Let's say you want to, change this to a 2.5 or something. You can see how what changes as you change things. The idea with the Help Center here is that it gives you a ton of examples to play with. And then through a lot of those examples, you can kind of find what you're looking for. So like this one says filling bottom. I wonder what would happen if I said filling above, maybe? Shift enter. Nothing there. So maybe top. Okay, so that's the right call right there. But let's say you tried above, it didn't work. Well, what you could do is type in the word filling and click I, and then it'll give you everything how the filling option works. It'll give you a bunch of examples. So it's a rabbit hole you can keep going down deep as far as you want, learning how to basically create any kind of animation you like. In fact, if you go back to our course and open up, let's say, this textbook, all of these animations were created in Mathematica, including, the sliders moving around. And surprisingly, this doesn't take very much code. If you wanted to learn it, I'm not a coder, but I could code this textbook. It's not as hard as you think. But we're going to be using a lot of this stuff, and if you wanted to, you could actually create a lot of this yourself. So if you want the like full version, you would need to download the desktop version of Mathematica, and that I think the cost is like $50 or something per semester. All I'm having you use Mathematica for is for basic computation. So let's go back. Let's head in. All right, so let's do some stuff. Let's say you wanted to take the derivative of the sine function times, let's say, x squared. And you can see the one thing that I'm missing here is I have to tell it what variable I'm differentiating with respect to. Shift enter, and there's the derivative. Let's say I want to learn more about this derivative function. Well, let's see. The D didn't, it's not enough letters. So I'll go to documentation and I'll just do search D. See what comes up here. There it is. There's the derivative function. We'll look at some examples. It even differentiates x to the n, where n's an arbitrary constant. What does this do? This is doing the fourth derivative. So you can kind of look at the code and analyze why is it doing the fourth. You can probably see why. This is the variable of integration, and that's the fourth. That's telling it to differentiate it 4 times. This would be the nth derivative. Um, so you can look at, play around with all this stuff. A lot of it we're not going to need because it's probably beyond us, but with the basic examples, you can get pretty far. Let's do maybe limit. You might run across that one. I'll click I here. Here's some basic limits. Here's a limit of sine of x over x. That's a popular limit from Calculus 1. It's one that you probably should memorize. The limit's 1. You could graph it here. This is what the function looks like. You could come in from above or from the left or from the right. That's the left-handed and right-handed limits. In any case, play around with it if you're interested. You don't have to use it, but it will help you on some of the problems. I think for this chapter, though, the main one you're going to want to use is probably this solve, because you're often going to be solving equations like x squared plus 5x equals 2x minus 6. Forgot the double equals with respect to x. And it'll solve that quadratic for you. There's 2 solutions. They're complex conjugate pairs. If you just want the values, there's the 2 values right there. And that's the I imaginary unit. Okay. Let's say you have x squared, and let's do another one, sine x. Didn't like that one. X squared equals sine x. Cosine. The system cannot be solved in method. Oh, okay. Yeah, this is n solve. So this does not have nice answers. Yeah, tons of solutions there. So if you graph these two, you'll see that. Um, but let's look at one integrate. X squared with respect to x. What this will do is it'll give you an antiderivative of x squared or an integral, right? Now, if you're finding the indefinite integral, there's a plus c on the end. It leaves it off by default, but if you want to turn it on, what is it? Generated parameters, and you can type in a c there, and it'll throw it in. But I usually don't write it in. I just remember. Or let's say you want to integrate x squared from uh, x equals 0 to 4. So that's a definite integral from 0 to 4. It's finding the area, the net area underneath the x squared function from 0 to 4. 64 thirds. So you could play around with this and you could say, okay, well, let's plot the x squared function from 0 to 4. You'd say, okay, well, we're trying to find the area underneath that. And I kind of remember that filling option. You'd say, okay, well, that's what I'm trying to find right there. So that area is 64 thirds. In any case, that's kind of a general introduction. I would probably take a look at this integrate function and just kind of look at the examples in here to get some ideas of what to do. But this will save you a lot of time, especially when you're checking your work. I would encourage you guys to use this as much as you can, but don't use it to do the problems for you. Use it to check your work, to check even solving basic equations, just to make sure that you did it right so that you don't waste another half an hour, using the wrong information from the part above it. Okay. And as we progress through the course, I'll probably be showing you some other functions. Right now, it's just the integrate stuff. There's some trig stuff you'll probably want to know. But I'll kind of throw out some videos and maybe some meetings when I find something that would be useful. But for now, it's going to be mainly the integrate function. You're also going to have to figure out when two curves cross, right? And that's just you would use the solve function for that, right? You can also, of course, do it by hand first. That's the idea, but then you can use this to kind of check your work. Okay. That was it. It was just a short introduction on the Wolfram Cloud thing. If you want to read more with docs, all the different functions this will do everything in the entire class, but you would just click this docs button and then you could investigate pretty much anything. Just type in what you're interested in. Let's say you're interested in series, which we're going to do later on. And there's the series function. The naming system that they've set up for this program is pretty nice because with the things that we learn, most of the time the name is what you think it is. There's one that's not partial fraction decomposition we're going to talk about later, and I don't think they named it like that. Let's see if they did. Oh, okay. Well, it is there. It's this function apart, which we'll talk about later in the course, but it basically takes rational functions and breaks them apart. We're going to do it by hand, but this is a really nice way to save you a ton of time checking your work. So, because these are a pain to do by hand. Okay, but we were not going to get to that part until much later on. All right. So there's lots of other stuff. If you're interested in doing any graphics or you want to actually download the real Mathematica, the one for your desktop, it looks something like this. Let me see if I can move this. I'll just show you one thing so you can see the power of it. Let's see, plot. Let's do a 3D one. You can use this in Calc 3. It's pretty amazing. Let's just copy this guy out. And what this is doing is it's plotting this as a surface. It's a function of two variables. So we don't talk about this in this class, but you can move stuff around. But one of the most powerful functions you can use is a function called manipulate. And what this function does is it allows you to put a slider up here, and then you can take that slider and you can control things about your graph. For example, if I put an A right here, now that A is going to be controlled by a number between 1 and 4. So you'll notice what happens. Oops, spread out for multiplication. Um, Let me put in one more thing to fix the low performance. Quality. And let's go back here. All right, so now you can see what happens to the surface as I change that value A. And it's all in real time, which is super cool. The Wolfram cloud won't obviously do this because in the cloud it has to send the code to the server and then wait for it to get back. But everything on the computer, it's all done on the computer. So it can do this stuff a heck of a lot faster. So you can pretty much create anything that you see in the textbook if you wanted to spend the time to learn it. It's actually not too bad to learn. So, all right, I'm going to stop the video there. Where's stop? Okay.